right, let's look at Rolle's theorem. And this one is the first theorem of the big theorems that actually relies on differentiability. Notice the requirements, the function. It starts with continuity on the closed interval. However, the open interval needs to be differentiable. And if f of a is equal to f of b, then there must be a point where the derivative is equal to 0. Graphically, the best way to explain that is if you have a function that begins and ends at the same value. Let's see if I can hit these points. And you are differentiable, which means you're smooth, no cusps, no discontinuity, just a nice, smooth, continuous function. If you are differentiable from a to b, let me try that again. I did the same thing. One more time. That's pretty good. All right. So if you are continuous and differentiable, then there absolutely must be a point where the derivative has a value of 0. In other words, you must have a horizontal tangent somewhere between the two endpoints if you begin and end at the same value. And it's guaranteed at least once. Could happen more than once. So this little quick example, a car is on the interstate traveling 70 miles an hour at mile marker 10, and again 70 miles an hour at mile marker 20. So you could say the velocity at mile marker 10 is 70, and you could also say the velocity at mile marker 20 is 70. We know nothing about the car's velocity between the 2 points. What does Rolle's theorem guarantee about the car's acceleration? And remember, acceleration is the derivative of velocity. So you could think of it as asking about the derivative of velocity on this trip. And because the velocity started and ended at the same value, then we know that there is a point where the acceleration is equal to 0 somewhere between mile markers 10 and 20. The one thing that this little situation did not stress is that velocity would be differentiable. I probably should have put that in the paragraph. But velocity is going to be differentiable here because that's the only way you can answer the question. All right, so moving on to question 2, and you are allowed a calculator on this one. This is an old free response question. However, the calculator is really not going to be of any use for this part. We have a table that provides the rate that water flows out of a pipe in gallons per hour. They give you values every 3 hours for a 24-hour period. And the question is there a time where the derivative, where r prime is equal to 0? And notice here they did say that this function r is a differentiable function. And so must there be a time that r prime of t is equal to 0? Yes. And anytime I see the derivative equal to 0, I'm going to think Rolle's theorem. And what I want to do is find 2 times somewhere on the interval where the r of t has the same value. And this one they made it easy because they stuck it on the ends. Sometimes you actually kind of have to fish around on the interior of the data to figure that out. But the answer is yes. If they ask a yes or no question, always write either yes or no. But then it says justify your answer. And when you justify answers using a theorem, you must establish the requirements for that theorem. And in this case, that is that the function r is differentiable and continuous. And even though they didn't say continuous, we know continuity because differentiability does imply continuity. So I'm going to start by saying r of t is differentiable and continuous, because that is the groundwork. That is what must be true in order to use Rolle's theorem. Then I'm going to say that r of 0 is equal to r of 24. And it's not a bad idea to go ahead and just say they both equal 9.6, although that last part is not actually needed. I will include units because that's always a good habit to get into also. So if a function is differentiable and continuous on an interval, and you have 2 values of t that return the same value of the function, therefore Rolle's theorem guarantees that r prime of t is equal to 0 for some t. We don't know where it happens, but it must happen somewhere on the interval 0 to 24. You don't have to say the name of the theorem. It doesn't hurt. But if you forget the name of the theorem, it's perfectly okay for you to just explain in your own words how you know that the statement is true. And here's another one. This one's a multiple choice question. You have a function that is continuous and differentiable on the closed interval 0 to 4. The table below gives select values of f on the interval 0 to 4, and it asks which of the following statements must be true. And must is a key word because it's very possible that that multiple questions are true. However, there's only one that absolutely must be true. And I'm a huge fan of graphing. If it helps you, sketch this out really quick. We have values at x equals 0 through 4, and it goes from 2 to 3 to 4, and it kind of goes up pretty nicely. 2 to 3 to 4 to 3 and back to 2. So I'm going to lock all that in. And then let's think about all this stuff as we are considering these options. So option 1, the minimum value is 2. Okay, well, we know there is a minimum value because the extreme value theorem would guarantee that if you have a continuous function on a closed interval. However, even though the data, what we have, does look like 2 is the lowest value, it's very possible for me to connect these points by starting with a downward motion and finishing like this. The lowest value does not have to be one of them they gave you. We don't know what's happening between these integers, which is the reason we don't know the minimum value is 2. And for the exact same reason, I don't know that the maximum value is 4 because I could go up really high and then come down and hit that 4 on the way. So that doesn't have to be true. F of x is positive. Okay, again, a positive graph means above the x-axis, and yes, all of these values are positive, but I could start by connecting these and then between 2 and 3 decide to dip down here, go negative, and then come back up. We don't have to remain positive the whole time, so that one's not true. Now, D is kind of tempting. If the derivative is negative, that means your function is decreasing, and from 2 to 4, we do have an overall decreasing trend, but I don't have to be decreasing the whole time. I could start by increasing and then decrease. And then I could increase again at the end. We don't have to be decreasing the whole time. So that one's not true. And the only one that must be true, and this one would be true by Rolle's theorem, is that somewhere between 0 and 4, there is a point where the derivative has a value of 0, and that's because we have a differentiable function that starts at a value of 2 and ends at a value of 2. F of 0 is equal to f of 4. And so it doesn't matter how I connect these, I must connect them smoothly because the function is differentiable. And if I connect these smoothly, there's no way I'm going to connect these without having a horizontal tangent somewhere. We don't know where it happens, but it must happen by Rolle's theorem.